Welcome. You're listening to How I Did That, a storytelling podcast. Let's jump into today's episode.
I'll let you guys just introduce yourselves first, and shout out to Matt if he comes on sometime during this meeting.
All right. I'm okay with waiting, but that's fine. Jaclyn, do you mind going first?
Hi, I'm Jaclyn. I went to Wayne State for chemical engineering, and I work at a chemical plant currently. That's really it.
Hi, I'm Rungus. I did chemical engineering. I'm your favorite STEM major's favorite STEM major, and I'm a STEM major who hates STEM majors. So, yeah, that's a pretty good description.
That was really good.
Really good. Great. Okay, so I want to start with high school. Did you guys both know, I'll include myself as well, but did you guys know that you wanted to go into STEM? Not specifically chemical engineering, but just STEM in general?
My background of why I wanted to be an engineer were two big things in my mind, and it's weird looking back to, it's been 6 years since I graduated high school, and then, the 4 years when I was a freshman or a junior, I read this article about these scientists that are trying to rewire malaria to make people resistant to AIDS, and I thought, that's so cool. I was usually a pretty smart kid back then. I didn't have the perspective to understand that there's some limitations you can choose. It was just, what's the most meaningful and helpful thing you can do? And the engineering joke that chemical engineers like to make, even though it's less funny and more just a statement, is the difference between being, as an Indian kid, you're lawyer, doctor, engineer. And I'm lawyers often look to compromise the morals. Doctors can only help one people at a time. But as an engineer, I wanted to go toward the biomedical end of it. So I knew I wanted to be sciences that way. Then I did my high school robotics team, and I got elected president out of spite because the kid that wanted to be president, we made him vice president. But I love the artistry of all of us coming with different minds and being able to see each other's blind spots. So I always knew that the difference between a chemist and a chemical engineer is there's a lot more of a grounding in people skills as an engineer. So yeah, in that avenue, that's what pulled me in that direction. I knew I wanted to be an engineer. Part of college was figuring it out.
Yeah, I think I knew in high school because when I was probably, a sophomore, we went to go visit my cousin, and she works in Virginia, and so she works for the Navy, and she develops weapons. I don't know, I just thought that was really cool, and she was an engineer.
Was she a chemist as well?
She was, yeah, so that's why.
Well, for me, because I was going to become an accountant in 12th grade, by the time we were going to be applying to universities, which is October of our senior year, I was yeah, I'm going to be an accountant. And then my dad's an engineer. So I remember him sitting me down, and he's hey, I think you should do engineering because you can become an accountant later. I didn't know really what degree I was going to do. I was just I want to be an accountant. I did end up going into mechanical engineering because I was just so lost. I ended up leaving that after a semester. And then I switched to chemi because I wanted to go to medical school, and chemical engineering, I somehow switched from accountant to engineer to wanting to be a doctor. It's really strange.
Doctor engineer, it's a brown kid's dream.
Yeah. So after that, I switched because I wanted to go to med school, and I was if I'm going to do engineering, chemi does have organic chemistry and other similar classes that I would need for the MCAT. And then after 2 semesters of that, with taking extra bio courses, I decided I just want to be an engineer, just a chemical engineer. So I kind of switched a lot before I decided.
I want to be patient just because while math degrees in and of themselves might be sometimes tough to figure out, actuarial sciences is a pretty big field in terms of making money quick, which is basically insurance math.
Oh, okay. Matt has joined.
Welcome!
Wait, I'm not familiar with Matt. Who is this Matt?
Hello, Matt.
Hi.
Hey, you're in San Francisco today.
Wait, I didn't mean to put that background, but it's there anyways. Let's just go with it.
Okay. Hey, Matt, can you introduce yourself?
So, my name is Matthew Colligan. I don't know if I've been mentioned in the podcast.
Well, I did give you a shout out waiting for you to come on.
Oh, okay. Yeah, so looks like the gang's all here. So me and Neha and Jaclyn and Angadbir have all been good friends in the chemistry department at Wayne State. We all just graduated just last year. I've been working at Ford doing compliance ever since. And yeah, that's basic introduction for me, I guess.
We forgot to mention how we knew each other.
Yeah, we did. We didn't even mention that.
We totally overlooked
You did
that.
great,
Yeah.
Matt. Once again, Matt's great. I'm gonna get off the chat, guys.
We were only on the first question, so I was asking everybody, like, did you know from high school that you wanted to get into STEM?
I mean, I didn't know for sure, but I mean, I had a strong, like, I knew pretty much for sure I was going to end up there. It was either going to be that or music, because I was super into band, but I just decided in the end that going into the STEM field would probably be a safer choice. Because, I mean, I enjoy that too. I enjoy both, but I just think it's more stable to go into a STEM career rather than music. It's kind of hard to make a career out of that. It was kind of a late decision too. When I was first coming to Wayne State, I was enrolled to be in the biomedical engineering program, and I kind of switched to chemi right before the first semester started. I don't know, I just kind of got a vibe that chemi would be something I'd enjoy more than BME. And honestly, I don't know if you guys have sort of the same rationale for it, but going into it, like, there's really not any great resources to know exactly what chemi is before you get into it. So I was just like, I like chemistry and it's an engineering degree. So I kind of that was my rationale.
Originally, I decided to go to Wayne State for BME.
Just a shorthand, I also wanted to be a BME when I started going to Wayne State too. I got talked out of it by a girl that was like, you get the same job as a chemi degree, and I thought she was cute, so I'm like, yeah, you know what? I just live life by the moment. That makes sense. It's better orientation.
Yeah, I was just going to say, I think based on all of us seeing Darpan's struggles in BME, I think we all can agree that we made the right choice in the end.
So for you guys, like, when you transitioned from your last year of high school to first year of college, what was that like?
I was like dead set of going to Ann Arbor.
Like the city of Ann Arbor, like what's there?
No, I wanted to go to the University of Michigan, Ann Arbor. And I was dead set of going. They didn't really give me any money because I didn't do those types of scholarships. And then Wayne State offered me a really generous amount of scholarship. And I thought of, like, if I go to Wayne State now and don't like it, I could transfer out and I will have lost no money. But if I go to Ann Arbor and don't like it there, and if I go to Wayne State, I will have left it on the table. And I went to Wayne State and really started to fall in love with the city.
Matt, please, go ahead.
Could you repeat the question?
What was your transition like from high school to first year of college?
Honestly, I was really discouraged my first year in college. Not class-wise, like, as far as, like, workload goes with classes, it was almost easier than high school. Mm-hmm. Just because I was taking all those, like, prerequisite classes that really have nothing to do with chemi. And, yeah, you just kind of feel like you're wasting your time. But it really came with my, like, living situation, because I went in to, like, one of those dorms where you share, like, it's like a one-room dorm with one other person.
Double.
And, yeah, a double. So I had two different roommates over the course of my first year, and they were both just really horrible experiences. I don't know, I was getting kind of, like, discouraged and a little bit kind of lonely, because I'm like, I can't relate to these people at all. Mm-hmm. And I don't know, like, how am I going to live with just randos for the rest of my time in college? But luckily I found a really good group my second year, and I lived with them throughout the end of it, and I'm still friends with them today, so that worked out pretty well.
Like, Angad and Matt, too, like, your academics first year, like, you didn't find it to be too much of a struggle?
I got a B in calc, and that, like, offended me, being like, I'm a smarty pants. I did good in high school, and I had to really learn how to be humble, and as you guys know, it's still an ongoing journey.
Well, what courses did you guys take in your first year?
Honors.
Oh, man, yeah, those honors courses, complete waste of time if you ask me. The honors courses
is just for people like who want to graduate with, like, with distinction on their certificate, right? Like,
yeah. So basically, my mind was, hey, you want this money? Yeah, take this class. I'm like, all right, let's do it.
Because your scholarship was based on, like, honors.
Yep.
Okay.
Yeah, mine too.
Yeah, Jaclyn, what was your transition like?
Wow. I am very resistant to change, so I don't like it. When I went from middle school to even high school, it was really dramatic. So high school to college, it was really rough, actually. Yeah.
Were you commuting?
No, I lived on campus. I have a really large adjustment period whenever I have a big life transition. So, yeah, I really struggled.
Academically or just like university culture wise?
Yeah, academically, I did, yeah. Not at first. I was doing really, really well at first, but then I think just because I really was like struggling with the adjustment period, and then also I just got really lost. So for the first semester, I did not really do that well. That was my worst semester.
For all of you guys, what courses did you take in your first year?
That's a really good question because I barely remember any of them. The class I remember the most was like general chemistry.
Your first semester?
Oh, with Barber, yeah, the big like 200 student class. Yeah, I'm sure we were in this. Yeah, we were definitely in the same class. I'm almost sure of it.
Barber's like, do your owl, and then like you would go take the owl, like you would take all the, like the little mini things to increase your learning, and it's like, here's a test, prove your learning, and you'd mess it up, and you'd go back a few steps, and it's like, I didn't ask for the test, I just want the number to go up. When I was a resident advisor, I saw a girl during a fire drill late at night, aggressive with trying to finish her Alex. I'm like, oh, poor girl. Oh no.
Yeah.
Oh wow, that's horrible timing.
I took Calc 2, Orgo 1, the honors class, and then the basic engineering class.
For me, I found the transition really difficult at first because I was in Windsor as a mechanical engineer, and the courses you took there, it was like linear algebra, like an engineering essay course, and you took mechanics, and you took calculus, and you took design, and I had a really hard time. There's not a lot of resources for the stuff we were doing. Were not a lot of resources. Anyway, so once I ended up leaving, the only course I could transfer to Wayne State was Calc 1. I transferred that, like differential calculus, and then the January to May semester was basically my first semester. Then I caught up with everyone's second semester in the summer. So second year, like I was ready to go with like the rest of the cohort. And then first year I took like physics, Calc 1 with differential calculus, and then integral calculus, MATLAB, general chemistry, if I didn't mention that, or physics if I haven't mentioned that, MATLAB, and we had to take like the chemistry lab. Oh, bio. I had to fulfill a bio requirement. I'm sure you guys did as well. And bio lab. I think I took an English course or the basic engineering design courses, yeah. Let's go on to second year. So how did you guys find second year? Because I know our first core class started second semester of second year. When did you start to get to know people within the actual degree itself?
Because I remember like in the first few engineering classes, I still didn't really get to know anybody too well.
Matt, we might have been in a similar scenario though, because it took us 5 years and it took them 4 years. So when we took the BE classes, the basic engineering courses, with a lot of the folks that graduated the year before us, at least that was my experience. I developed friendships with many of them, but it just, we didn't keep up because we just weren't in the same classes as much anymore.
I don't know if this was your guys' experience as well, but for the first year, I made friends, but nobody was in my major. So everyone kind of like, you made a lot of friends in bio, orgo, chem kind of thing. And then they all just kind of drifted apart because they weren't in your major.
I had like a group of friends that were like electrical engineers and like bio majors, and I barely talk to them. Actually, I don't talk to them at all anymore. We did kind of just drift apart.
It's hard when you don't have the same classes like after second year because you don't really have any reason to see them around because everyone's like different schedules. Going back to the other question, what did you guys take in your second year?
I just want to respond to what y'all are saying. I didn't really have that experience because I made friends through my honors course, some of which because they happened to be in my same Gen Chem and like my Orgo 1, Orgo 2. I ended up taking Calc 1, getting a B, being offended, took with the Emerging Scholars Program, and I made a lot of friends in the math department over there. I ended up working over there, and I have like a good, that's why I have a math minor, is because I had a really good foundation of friends that were in that chemistry end of it, and then happened to transition to that math end of it. And it was like every Friday I go see them. I really didn't feel in touch with my college experience until that happened. I had a similar experience with a roommate that I was really excited to live on campus to make new friends, but I had a pretty antisocial roommate. So it just it just wasn't happening. I was making friends, but like I make weird first impressions because I'm pretty eccentric. And then I had developed, other friendships, and then it was a lot of not knowing who I was. So even though it only got strengthened once I started getting a better sense of my own personality.
I think by the end of my first year, I had made some really good friends, and I had some really solid relationships of people that I still talk to today all the time. I mean, at that point, I had met Laura and Nazir. They were both in my BE class, so yeah. And then also I had made some other friends that were just in my honors class too, like Angad. So yeah, I think I was in a really good place by the end of my freshman year, and then going into my second year, I was really excited to go back.
Yeah, going back to that question, what courses did you guys take in your second year? Or in general, what do you think people would take in their second year?
So I think it's important because we've had different experiences to separate it from before the CAMI program, and then once we got to there were statistics, there was MATLAB programming, Physics 1, General Chemistry, Orgo 1, Calc 1, Calc 2. I think we need to have had taken Calc 3 by the time we got into a program. It varies per university because sometimes they have a very accelerated program, they'll use a lot of classes back to back. So that's not a universal experience, but that is a very unique thing in college, in that in high school you have the same kids in your grade and you almost see them all the time, and a big part of college is recognizing that you're not going to make those long-term relationships outside of that repetition in classes or having some external thing of being in a club or having that. I think Jaclyn had a unique experience, but again, it was seeing the same people in classes and developing a friendship that way because you drift apart. It's a normal thing.
My second year, my first semester, I took differential equations, material science, and then I took a technical writing class, and then Orgo 2. I think that was it for me. I might have had a lab in there, but yeah, that was good. That was a good semester.
I think I'm trying to remember, the way I did it was super atypical because I got away with not taking a single engineering course, I think, until the very end of second year. That's when I took my first one. I think that was the first basic engineering class with High Peng.
Was your basic engineering with High Peng?
I think so.
Well, yeah, he was my first chemical engineering class.
Oh, sorry, that's what I meant. That I got away with not taking a single chemical engineering class until then. I think before that, I did take the basic engineering class, the one where you had to do the robotics and stuff like that, the programming.
Yeah, Legobot and Arduino.
It was okay, I guess. I didn't like it that much.
I did really good at it, but my professor, who we met later on, kept calling me Ong, and then he didn't bother to learn it. And I have grievances with Wayne State's engineering program, but whatever. But I'm sorry for interrupting.
In my second year, I took vector calculus, Physics 2, and differential equations, material science, and some electives. I had one of the technical communication classes, organic chemistry too. Oh, I took cell biology because I didn't need to, but I was kind of on the bio track. I was taking extra bio courses, and it didn't even count as an elective, so that was a waste. Matt, you were saying you got away with not taking any chemi classes until second year, but I think that's when everybody had to take the first class. There were no other. That was the first.
Same thing. First chemi class, first program would have been. It pisses me off because they only ran it in the winter. That's the reason why I wasn't semester behind. That's why we were a year behind.
For the listeners, that your guys' timeline was 5 years, right? So you're talking about you took it in your third year. In general, the way the program was structured, it's second semester of your second year, you take the first chemical engineering course, which is materials and energy balances. I thought it was really, really interesting. How did you guys find it? But I thought it was way more difficult than any class I had taken up until.
Yeah, that was.
I got the highest score in the first exam, the lowest score in the second exam. It was in the morning. They told us a third of us weren't going to be there, and with good intention, because High Peng was saying that you can't let people go on to learn the material. But that's a weird mixed message from the university, because it's then why not run it in the spring and winter? And it's nuts that Wayne State can ask for so much tuition and be we just can't do it.
Yeah, they only offer it once a year, but I think they started offering it in the summer semester as well for some people, so they could take the next course in the fall.
That was only because a bunch of people failed. and that makes Wayne State's graduating numbers look bad.
Wayne State's graduation rate was like 20-something% a couple years ago.
I thought it was a great class.
Yeah, like
I really enjoyed it, and I did pretty well in it.
And it was really interesting because, yeah, there, like Matt mentioned earlier, there were no resources on our school campus to understand what like chemical engineering was until we took that class. So
yeah.
I think we should mention to the listeners what the first course was even about. Like, what do you actually learn in that class?
Oh, mass and energy balances?
Yeah.
It's important to illustrate it that it really is the fundamentals of everything else.
It really is, for sure, yeah.
It's almost like an engineering problem-solving class of learning how to think like an engineer by virtue of thinking in terms of inputs, outputs, isolating systems, open systems, and like it's a lot where that's introduced, and it's built on and like thermo and separations that they are. For as much as chemistry and physics are part of the mix, it's the first organized engineering thinking of thinking, because all engineering is problem solving in a given system. If you're a mechanical engineer, you're solving the mechanics of the system. Electrical engineer, you're solving the electrical end of the system. So it's the first class where the basics of engineering is you solve the material going in, the energy going in.
It introduced fundamental concept that when you have a system, the mass can't be created or destroyed, so the mass going in is going to be the same as the mass coming out. And like it could change form, but it's going to be the same mass going in and out. And same with energy. Like the energy can change form, but it's going to be the same on either ends. I think that's probably the most fundamental concept in chemical engineering as far as everything we learned. I think it was a good first class to take.
I really think it encompassed everything.
I learned how air conditioners work. We had a question on mixing strawberries.
Yep, that was the one that I remember the most.
And like dew temperature, dew point. What was it?
Yeah.
Dew point, bubble point.
Yeah, dew point.
Yeah.
Was that in that class, or was that thermo?
It was introduced in that class, so yeah, that was a great class. I know we talked about vapor pressure. That's very relevant.
Because it's the idea that the mass is changing state, but still in the system moving around. It's a mass balance.
Well, yeah, we learned a lot, like all the fundamental definitions, just every equation, like there weren't even that many equations. It was like the concept of setting up the balances that you really had to know.
I did not have the greatest experience, and I think it's relevant because it painted the rest of my experience moving forward. The most important year to understand, do well, and learn of the fundamentals. Because I think about it, like maybe it would be better if I retook that, because I had just started working like a few different jobs, and I wasn't getting any sleep, and I was behind in class, and then I would not understand material. I'd stay up late to study. I wouldn't get any sleep. I started to get sick, which would make me miss class. So it was this vicious cycle. To the point where like I was understanding it from the beginning very well, and then after that, I just didn't feel the connection of understanding it. And really, it's a true form of my own mistake in not knowing asking for help is supposed to be the norm. If you don't understand it, you have to take the effort to go to the online. Khan Academy had all that stuff, like there's other websites, Learn Chemie, all those resources were there. Talk to professor, because I think if you come from a place where it's not normalized to ask for help, you really screw stuff over. And like I would have issues in my other classes, even when I was in the ball, because my fundamentals weren't sharp. So it was literally a thing where the tutors were there, the professor was there, then the online researchers were there, but I just kept convincing myself that, once you attribute guilt to your own failure and not to like, the engineering mindset's a problem-solving mindset, right? Not like necessarily a fault-finding one. Because we did not have that peer support network established, I only started thriving in chemical engineering once, I think Christian Neme, who I think works for AK Steel, who's a phenomenal person, said it best, where everyone eats, where we legit just started doing homework together, and my greatest memories of chemie is when we were looking out for each other, and like that's the reason why I say I resent STEM majors, because they're kids that would do phenomenal in the courses but wouldn't look out for anyone. Because I think they're looking so closely pursuing validation that they're always going to put up people that were like them and put down people that weren't. I think we need more engineers that care about people.
So third year, but how did you find your third year of the program? So I know Angad and Matt, like your third year.
Second year of the program.
Well, for you guys, it would have been your fourth year, right? Instead of our third year would have been your fourth year.
Right. It would be like theater, appreciation, 1,000, and you just like take the class online.
Oh, yeah.
History, ancient civilizations, and I don't care about that. Did you guys take that class, music appreciation? Yeah, there's a Canadian history one, and it's just like, come on.
That's what I took.
Just let me not take the class.
I took history of rock and roll, but they kind of balanced out the really hard classes.
But yeah, so for third year,
We became friends in that year.
Yes.
we all had the same courses by that time. Everyone had to take the same sequence of courses. So first semester in the fall was thermo, and then fluid flow and heat transfer in the same class. Let's talk about those for a bit. How was your experience with thermodynamics, guys?
I think it wasn't about the grade, it was about the friends we made along the way.
Yeah,
I agree.
I think after I got through 2800, not really collaborating with students with my peers much, but by third year, you really see the importance of needing a group of people to do homework with. And everybody has their own group of friends kind of by then to study with. Because we had to sit at circular tables as well in that class, so whoever you were sitting with, you kind of ended up
I kind of am now wondering what 2800 would have been like if we had circular tables. With that
The circular tables really are a beautiful thing, honestly.
Yeah.
Because everyone, it's like a lunch seat where everyone needs to pick a spot, and you're like, you seem cool.
Exactly.
The main thing I want to say about that is I'm really glad we took thermo and we did, because now it's entirely MATLAB based. I suck at MATLAB, so that would have been a really tough time for me. Mm-hmm.
Yeah, but Panoff is once in a generation talent when it comes to how much he cares about teaching.
So, for that class, we did, the general, steam tables, enthalpy, entropy, Gibbs free energy.
Yeah.
Vapor, liquid, was it vapor, liquid diagrams? Phase diagrams?
Phase diagrams.
It was an extended form of 2800 is what it felt like.
Yeah. And then gas.
Honestly, I thought it was very well taught. Maybe that's why I think it was, one of my favorite classes of my college career, but also because I met you guys there, so that's probably why I liked it so much. I don't know. Maybe.
It was also one of the easier ones that we took, too.
That's saying a lot.
It is, though, because, it's still really hard, but it was easy compared to some of the other ones we had to take.
Really? I felt like
kinetics. I remember on the exams, a lot of the exams was, using those steam tables in the back of the book to get values and just plugging them into equations.
Well, and very much it was a case of do the homework problems thoroughly.
Yeah.
And we would just be just check it out or, find the solutions. And then, oftentimes when I didn't do well on exam questions, it was because I didn't understand conceptual homework question. So it was just it was a lack of preparedness. I will say that was part of the difficulty there.
So then we at the same time we were taking fluid flow. Fluids and heat transfer were half and half.
I loved it because I could see the BME squirm.
I don't think fluids was as well taught as thermal for sure.
Yeah, no.
It was
Dr. Sally just barely cared.
I mean, you could pester him and he would give you a thorough walkthrough on it. And I thought I don't know, I thought the material was cooler there because it felt a lot more practical in purpose in terms of just, you can't just have this ideal scenario every time, right? There are known coefficients for known materials. But yeah, I just loved watching the BME squirm because, a lot of it was online and people would buy checks during the exams.
Yeah.
Not to mention names because we're not snitches. To me, it's not about the good people succeed, it's that bad people fail. Biomedical engineers, the Franklin major of Wayne State. Definitely taught the importance of that peer support network. We started doing homework together, we started having group chats. I wish that the system always pushed out people that weren't ready for it. But we saw it happen where, it definitely shows if you have a qualified professor like Potoff who's really going to stretch and squeeze the lemon of your brain, that there are people who tried to cheat or tried to go by, every skate on by without putting in the work, and they got booted out of the program then, too. Not to say that everyone does bad because they aren't putting the effort in. There's many different reasons you can do bad, and like you can't judge yourself. There are kids that are like, oh, my parents did this and this for me, and it's like, yo, I gotta work, and I definitely think it's important to remember that grades don't always equal grit.
Yeah, for sure.
So, like, me and Matt became friends because we sat by each other and we'd ask the exact question that
we would sit near each other. We would like
both have the same question in our mind.
Yeah, and one of us would ask the TA, and the other one was close enough so that they can listen to the TA's answer and get the help without actually asking the question. And we sort of like spread it out so it didn't look like one of us was asking too many questions.
It wasn't pre-coordinated, and it's like that's I think the most beautiful type of friendships where just like, oh, this is just working now. We're just gonna keep going. It takes a village to raise an idiot, and I'm glad I had my village basically in Chemie.
So now going into second semester, what did we take there?
Kinetics.
Yeah.
And then separations. So yeah, some people might call kinetics reactions.
Or reactor design, and then
reactor designs, and then we took separations
and mass transfer. Even mass transfer together in one course.
And that was a great semester.
And we took a lab that semester, right?
Yeah, and that was a great lab.
Yeah. So in kinetics, let's talk about that experience. I found that to be one of the hardest courses.
Yes.
Because although the concepts actually seemed way easier than thermo to me, the way that you have to solve the problems was like way harder.
I want to bear in mind that it's not always the conceptual thing that's the hard part, because I really respect Dr. Nicola because she knew that like we'd be in industry and sometimes stuff is directly affecting people's health. So she's like, I'm not going to take it easy on you ever,
Yeah.
But then you look back at it and she totally did sometimes.
Yeah. Also, there weren't many equations in that course, though. That's what I found really difficult because you had to derive a lot and manipulate things without just plugging in. Yeah.
I mean, there was one basic equation that had a bunch of different variations to it. It was the rate equation, but there were so many different ways you could change that, depending on like what type of reactor you had or what type of reaction.
The design equations for the reactor, yeah.
Yep.
Yeah.
That was basically the only equation for that class, but you could vary it so much, and that's what made it pretty difficult because it was hard to.
And it was remembering the simplifications.
Yes.
Yeah.
Yep. I thought that class was a really great class, and just the critical thinking we had to learn from it, and then also how challenged we all were. So how much it brought us all together as a group. Yeah, that was great. That was really good.
Same.
Like one thing I want to mention that I think was lacking from that kinetics course. You guys might agree with me or not, but we were introduced to all these different reactor types, and we really didn't know what these reactors were or how they worked until we got into like some of our safety courses, and we were like seeing actual footage and like pictures of these processes in action, like because we learned about like fluidized bed reactors or like batch reactors and all the different types, but like you just have a concept like floating out there. You don't really know exactly what it is. Because it could have benefited to like know a little bit more about what's going on.
Sometimes it was like a conceptual gap, and then like the reason why I said it felt like a monkey because it'd be like, oh, that means this, and this is a CSTR, and this goes here, right? We had professors that'd be like, think about why we're using a CSTR, and we're like, we have no idea. Just give us the reactor. Stop asking us to think. You're totally right, but like you're trying to manage so many different things, you don't recognize the importance of that. You're right that like there's a reason why certain things are used, and like we didn't have any real in-person idea of it, right? We could see it in real life. We could have done 100 problems of it and not recognize it. Like that's legit a problem.
Kinetics is definitely where like our shared suffering cemented our friendship, I think.
Mm-hmm. Oh yeah.
Like kinetics is definitely where it was like, yeah, these people are going to be good friends for the rest of their lives. Most importantly though, I think perhaps the most important part about kinetics, this is where we were introduced to
No, dude, don't bring a disrespect. Like, look, I can't talk about him and give him his due respect. All right, so I think we should avoid it because that man will be the president one day. He has so much.
What are you talking about? We can't talk about. He's integral to our chemie experience, though.
Yeah, but like he has the energy of a con man, but he technically, other than fail everyone in every group project, has done nothing to deserve it. But like again, he's going to be a CEO one day. That man will fail his way to the top.
Controls project with me.
I just remember being in the
Oh my god!
and the only people I'd see are you and I'm like, where is their third member? And then
he didn't do anything.
Yeah, and didn't he message you the day of?
He never showed up. He messaged at like 3 a.m. the day the project was due. What about my part? Like, what do you want me to do? I'm like, don't worry. I know you're super busy. We'll take one for you.
We did have a lab that semester.
Yeah, I remember that, where we had like all the makeshift reactors that like never worked, and you just had to fudge the data.
Yeah, we had a heat exchanger, and we had other so in that lab in third and fourth year, and for the listeners, in third and fourth year we had labs where we were able to do these chemical engineering experiments and apply things that we learned, which was nice because we got to do them as we learned them. Yeah.
The labs at Wayne State are a complete and absolute joke.
Yeah.
And if we got ABET accreditation, we do not deserve it by virtue of chemical engineering labs alone. And anyone that wants to be like, that's a lot to say, go into those labs right now, find the old reports they leave out, and then talk to me about it.
It was just such a messed up situation with like the data that you had to present from that lab.
I'd be like, hey, it's all wrong.
You get the most messed up numbers, and they'd say that's fine as long as you rationalize it, but you weren't allowed to use the equipment sucked as a rationalization. And it's literally the only rationalization for why the numbers were so messed up.
But the intention was there. I mean, having to write the lab reports, I guess you kind of had to get a better understanding of how it was supposed to work, even if our equipment didn't fully work. And I remember when it was one of the labs where it was supposed to rotate, the blade was supposed to rotate, and she put it on full speed, and it
Yep, I was in her group. that was us. She entered in the speed, but multiplied by a factor of 100, and it flung water everywhere.
Okay, third year was really fun. I felt like that was the year that I learned the most. Ending third year, though, I was not confident that I could work in industry if I had to. I think fourth year really brought everything together, but I did learn the most theory behind the chemical engineering stuff in our third year. So then moving to fourth year.
We were blessed to have Durand as our product and process design teacher.
I was like the anti-Nicola.
Yeah,
but they're both brilliant. They're both super brilliant.
No, I know. I agree.
Yeah.
Personality-wise, just complete opposites.
Yeah, she really gave you every chance to succeed. And the material was difficult, right?
No, but Nicola gave us every chance to succeed, though. Remember that final? She definitely threw us a lifeline.
Yeah, and then people in fights been like, give me more. And I'm like, shut up now.
Well, I'll never forget when she gave us that exam, and it was tough, and we all did so bad, and she gave us the exact same exam. And then however well we did on that exam, it was just added as straight points, not even percentage, straight points. Yeah. Mm-hmm. And that was this woman, she wants us to succeed, and she just wants us to learn.
Mm-hmm.
Yeah.
And that moment, I was like, I gotta learn. I was like, I have to learn. I'm 21 years old, and I don't really care about learning right now, but I have to.
Mm-hmm. Mm-hmm. I sometimes prioritize getting grades over learning, but I think it should have been the other way around for sure.
That's why I feel like it props to Wayne State, that it really made sure that I learned the material before the grades showed up.
Yep.
Mm-hmm. In our first semester, though, we had product and process design where I really felt like that class kind of said, I did not even know what a flash drum was at the beginning of that course, even though we spent a whole unit talking about it in thermo. At least for me, I really ended up learning how all of these different engineering chemi units fit together to make a process. And we had to design the whole thing. We had to learn Aspen, like the chemical engineering software, which we also did in separations. But, oh, I forgot to talk about separations and mass transfer. Yeah, let's go back to that.
Yeah.
Okay, let's go back.
Go back. What did we learn?
Was that with Dr. Zhu?
Yeah, BPE, Big Zoo Energy.
So we have mass transfer and then separations. Mass transfer, I feel like I know they changed the curriculum. I think it's now integrated with the heat transfer course because it's kind of related. What about separations? What did we learn there?
Distillation.
Yep.
Distillation.
Yep.
Distillation.
Yeah, I mean, the fundamentals of distillation, which is so important because...
Did we not talk about flash drums and other ways to separate materials?
We did. It was separation, so we talked about everything. That was a great class, too.
Yeah. So
the distillation have too many column.
Oh my god.
Not that class. Like, come on, Lute. Save the bright spots for later.
What other separation units are there? Like adsorbers and absorbers?
Yes.
We are not representing the chemies well.
No.
What did we do?
We did adsorption, with absorption.
But the main focus was on
Scrubbers,
Scrubbers, yeah.
And then we used HYSIS.
multi-level systems. Yeah.
And that was a great project, looking back.
Yeah. Mm-hmm.
Great project.
Yeah. So the project was like designing a distillation column with certain specifications on HYSIS, which is a subset of Aspen.
Yeah.
Yeah, they're owned by the same company. Yeah, that was a great project, and I learned a lot.
So now let's jump back ahead to fourth year. So in our first semester, we took product and process design, which is what I was just talking about, and then we took control theory, and then we took a seminar and a lab.
I was talking about product and process before I jumped back to separations.
I hated how irrelevant it felt when it came to the senior project because, we worked our butts off to learn everything on that. We would intentionally get the worst grade to make sure we understood it more, and then be like, "Sup, bioreactors? You can't use any of these, stupid." Or imagine if we had a senior project that was in line to what we did with Durand, or just what the year previous it did. We would have zoomed through it. We would have put the full thing. And beyond that, Wayne State needs to rework its controls program if it was anything like we had, because truthfully, who felt comfortable walking away from controls?
No. Yeah, so from working on a chemical plant, so the design class, super beneficial to my development, and it comes in handy very frequently, but controls is something I needed a very good understanding of, and I didn't have, and it's hurt me and it's bit me in the butt. And luckily, I work with some pretty good people who are good mentors that will explain the control system to me, and I've learned a lot from there, but I do wish it would have been better, but also working with other people from all different kinds of universities. Nobody likes their controls class, so I can't fault Wayne State for not having the right one, because I don't know of anybody that has been able to say that they had a great experience, so...
Well, I get that. I agree. It's not an easy course in and of itself. We use cheat sheets and we're oh, it's fine, but I want to be mindful by saying that was the hardest part for us altogether, because life goes in so many different ways. What we did by then was learn how to rely on each other, learn how to rely on online resources, how to dedicate time into it, how making things a priority. Yeah. I think it's less about the material. Every major is the same for the most part, that you learn how to prioritize what's important, right? Because if you came in with your 2800 energy into product and processes, who could win that fight, truthfully?
2800, referring to, for people who don't know.
The first chemical engineering course, right? Even if you knew everything going in, you changed the entire style of how you were doing things as you went on to adapt. Yeah. Mm-hmm. And you would be destined to fail if you just... So it was learning it on the go and recognizing a failure is part of the process.
Yeah, I think that was the most important thing, is just changing your learning style, adapting. Yeah, you said it best. So moving to our very last graduating semester, your fourth year is when you could basically take electives, because for us we had 3 specific areas you could specialize in. So you could graduate with a chemical engineering degree, but it'll be with a specialization in nanotechnology, biochemical processes, I think, and then product and process. most people became product and process chemical engineers. And everyone did have to take the product and process design class anyways, but on top of that, if you specialized in like the nanotechnology or the bio route, you would take a couple extra, like one course, I think, related to that. So aside from electives, which I'll get to, we took process safety, where you basically talk about like just safety of chemical plants is really important. So that entire class was dedicated for that reason. We took another like
process design.
Yeah, we took another process design class, but that was more like heat exchanger integration.
And then second half was design.
Yeah, that second half was the capstone design. Most engineering programs, they get an entire year or maybe 2 years for their capstone design, like their final senior project. We had a month. So we'll get to that. I mean, we took design of experiments, like kind of a statistics course.
Yeah, Heinz is a gift to the university too. Quantum quick careers, y'all. Like, letting you know, just because his focus was on having the industrial understanding, and people see him as cheesy, but like, you know, safety was mad useful. DOE, like, everything had a cause and effect, and he had so much extended experience that like you really could see that connection being there. And like he was just so giving too, of being like, hey, you guys had a take-home exam? That was great. You guys want to keep having take-home exams? It's like, yeah, you got it.
We got really lucky that semester. We had snow days on like all the days we had exams. We had a snow day, and then things just ended up becoming take-home almost that entire semester.
So is that how it started?
Yeah,
the first exam was on a snow day, and it was like a week until I think it was like right before a break. So it was going to be on one of the last days before a break. We got snowed in, and they're like, well, what are we going to do? And it was like, we're just going to make a take home. And we all did well. We gave very complete and fulfilling answers. And like Heinz is like, let's just keep doing this. And we all went in. We worked hard on those. But we forget to think sometimes as engineers in academia of like, we're just like, solve the problem. But it's just sort of like, how could this kill someone? And like, you just got to think about it from that perspective sometimes too.
Mm-hmm. There's a lot, I feel like there's a lot I missed in process safety. When you're trying to think of all the ways a chemical process can fail, there's a lot to think about. It's not just say, oh, this can leak or that can break.
Yeah, I thought that was a great class, and also I thought it taught really good fundamentals. But then at the end of the day, I mean, you got to learn that in industry too, and there's people that are willing to teach you. I'm always working with the environmental group, and we're always challenging the safety limits, like, oh, these should be lower, these should be higher, you know, because you have your max operating working pressure, and if a document, a standard operating procedure is not well written, then it might miss that. You always have to challenge those limits to try to make sure you're being as safe as possible. And I think that safety class did teach you how to challenge things. And also, I thought it was good because we had that problem where it was, I don't remember what process it was. It was some process, and we had to challenge everything that could go wrong with it. So that's basically a process hazard analysis, which is really relevant in industry.
I remember we did a lot of analysis on previous engineering disasters, like chemical plants that had exploded, or other like the Challenger, Columbia. So
on our exams, we had to do like emissions calculations, and those are also very relevant to industry too. So those you need to know how to do.
Sometimes I know one of them where it's, what do you do? And it's like, you can't do anything. Like with an emission, or there's a speed where it's just like, it's going to hit a dude on a boat. What do you tell him to do? You minimize the damage.
He's already dead.
Yeah, you you have to... It kind of forced you to have those realizations, which is just like, even a little disaster is a big thing, you know?
Yeah, so we just had that one, the process design class, like the second semester one, and then we did our senior capstone within that class. Then we had the process safety, and then we had our electives, which like we took design of experiment, and then first semester I took an elective for fundamentals of battery systems.
I was in your batteries class with you.
You were.
Well, did you guys ever hear the story of my battery's boyfriend?
I did. I don't know.
No. Creepy dude, is that the basic gist of the story?
Creepy dude. So one time, I came to class and I sat next to him and I left my phone out and he took my phone out of my bag and he literally programmed his own number to it, and I was in the bathroom and I came back and he was calling him so he got my number.
Oh my god.
I feel like it's cute.
That is crazy.
Stab you, but like it also could have been the beginning of a tragedy of like,
how did you react to that
thing?
I just came back and he was still calling, so I hung up the phone and I was like, what whatever. Not something I really want to confront right now. I was like, I'm just not feeling it. I know that my face looked very disturbed, so I think he got the message. But who knows?
I took quantitative phys, and then I took the global engineering experience in China, which both were good. Quantitative phys was interesting just because there was a bunch of master students, and it's like, it did not feel master's hard of what I ever imagined it to be.
Quantitative is like physiology?
Physiology. The quantitative phys was a lot more about taking engineering principles and using them to, yeah, I guess it is biology, but like strictly having numbers associated with everything. Like, I know it sounds really basic, but you learn about biology, and I think in a very annoying way that doesn't click for me. I'm like, bring flashcards! Ooh, flashcards! You remember it? Did you remember your flashcards? That's what I treat bio as. This one directly had numbers that had cause and effect.
Jaclyn, what did you take? And Matt?
Polymers.
Matt and I took polymers, yeah.
It was just about, like, polymers in general and how a lot of times they're used because they exhibit like wildly different properties than normal chemicals.
Polymers, reactions, and then properties.
Yep, that. Yep. And we went full circle with that one, and it was Hai Peng was the professor again.
Then going to the final capstone project.
Big thing about it that we were in a unique spot, Jaclyn not being in our group, is that the first week I felt like we lost. I remember being out of the mix, and then we even of having the 4 weeks, we pretty much had 3 of the weeks. But really it was an exciting thing because we also had limited knowledge because we were told, hey, biological reactors, you're never going to use that. Don't ever worry about it. Worry about this stuff for class instead. So it felt like we had to relearn everything up until that point, right? Mm-hmm. And we found out while we're doing it, a lot of those principles still applied, but we felt completely out of our depth. But I think not having enough time and not having enough resources is probably the closest mirror to industry that we've ever had, right? That industry is fine when things are easy, but the real thing that tests your ability is when it's not. So I definitely learned that having a peer network that you can rely on. I owe you and Matt a lot for that project. I wouldn't have succeeded without having people I knew I could trust, and there's amounts that you didn't need to communicate. And I definitely think that project, for me, at least learned something important, that planning is almost always worth it, right? We had 3 weeks left, and we were in that scrambly phase of we're behind, we need to catch up. But it did us so many more favors to literally just spend days thinking about it, planning it out, what happens next. And then we were able to just go ham on everything else from there.
That was the craziest 30 days of my entire career. But for listeners, the actual premise of our project, so the American Institute of Chemical Engineers, the AICHE, releases a project every year where people can compete and send in their designs, but our school decides to take that project and give it to us as our final capstone. So other engineering programs, I know they usually get to choose what they want to do. For us, we didn't get to choose, and we don't build it by hand. We simulate everything. We had to create a we had to create a chemical process to produce ranibizumab, and it was based on E. coli, so you had to do bioreactions, and then you had to do the whole wastewater management system with it. The prompt was very vague from what I found. We had to make a lot of assumptions and basically just figure out how biological reactions work. Me and Anga and Matt, we were in one group, and Jackie was in a different group. I really think that project, after everything we learned in every single course, it came in helpful because we did mass and energy balances on there, and we did Aspen, we did the whole modeling. I don't think we used any controls, right?
Yeah, but I think that was our foundational insecurity on that too. I definitely want to give props to that. It was probably the truest form of engineering we ever did, because engineering is that problem-solving ability, and you either know how to do it or you have to do the research. And I remember us spending time just reading research paper,
yeah.
Finding the 2 or 3 lines that were relevant and then sending it to the rest of the group. And it was awesome going from a place of no knowledge to having that full extended report. It was not awesome not sleeping, but that's academia. We treat that as normal.
Well, the year before us, they had to make nylon 6,6, right? They had to make a polymer.
I don't feel bad for them. It definitely affirmed my own ability that, like, I went from I'm not qualified and, like, that's the imposter syndrome talking.
Jackie, how was your experience on that? Because you weren't in the group with the three of us.
I think it was a good experience to just challenge ourselves because the bio aspect was something I was never super strong on. And so just to challenge ourselves and have to make a pharmaceutical drug, that was really tough. But I think it got done, and I think that, I think it was a good time.
It was suffering, but I cherished it.
Yeah, I really did.
I do too. Mm-hmm.
Okay, so we all graduated. And then after graduation, what kinds of fields can people work in with this degree? Not even just in Michigan, but in general.
Whatever you can talk yourself into.
I mean, let's focus on a couple, because you can go into the pharmaceutical companies. You can go into batteries, fuel cells, batteries in the automotive industry.
Absolutely.
You can do anything else in the automotive industry as well. They will hire chemical engineers for a lot of like mechanical related positions as well. I think it's kind of close to mechanical engineering. Like if you were to compare to any other major, I'd say mechanical is like the closest you can get with the thermal overlapping fluids. You can go and work in like an energy power plant, like DTE, a coal power plant, nuclear energy plants, because DTE has the Fermi plant in Michigan, right? Environmental health and safety.
Yep.
And you can work in obviously oil and gas, which is like not anywhere near Michigan.
That's dumb money. That's moolah.
I mean, I know specifically they have petroleum engineering degrees, but like the chemi degree is very generic that you can very well go and work in that.
The truth is, beyond just the class, it's where you do research, where you intern at, you know?
Yeah.
And like my biggest mistake was not being more ambitious on getting that experience, because once you have the experience, truly it's not the experience that gives you anything, it's the ability to talk about it with true knowledge. That's what really like sells people in interviews.
Yeah. I'm just reading a couple other things so you can work, I mean, because although you're a chemical engineer and you don't do as many high-level chemistry courses as a pure chemist, you can still go and work in a chemistry lab. You definitely have that knowledge, separations, and all the other things you've done, like in organic chemistry labs and stuff. You could work as a chemist. And you can work in places like when you do product and process engineering, many companies have a chemical process, as long as like when they're producing an item, like there's always a chemical process involved, where you can work in like food processing, like Kellogg's, or you could be working in like the makeup industry with like chemicals there, testing and research. Or you can do higher education. You can get into academia, or you can get into research, and you can get into materials. With any industry, there's probably materials involved. So I felt like it was actually one of the most versatile engineering degrees.
I think we're self-absorbed as engineers to think our tribe is better. But truth be told, you can put a mechanical engineer, sometimes like chemical engineer's shoes. A lot of what you do is you learn on the job anyways.
Yeah.
And it's, are you learning the right things? Like, did you get the A's? That's great. That's phenomenal.
Yeah.
But are you in a space where you're listening to others? You're learning from them, right? Are you in the space where you're going to be quick and pay attention to detail? Because the most brilliant academic in the world, it translates a lot of things, but you know, you learn so much of it, right? And chemical engineering is versatile because it gives you fundamentals, right? That's the reason why a lot of us chose it. But also, I'm not so hoity-toity to think, oh, I'm better than a mechanical engineer in any given position just because I'm a chemical engineer.
Yeah.
What research do they do? I don't know their story, right? What workplaces do they go to? So the degree itself does matter, sure, but it's also like the strength of the program you have, the strength of the peer support network. I think we're better off than the BMEs, one, because we didn't choose to go in pre-med, but two, because we have this extensive support network that I hope goes on for years and years, right? That like maybe it might be, hey, I'm working in this place now and they're on the come up, they're looking for this type of position. Those contacts you make early matter, right? Those professional mentorships matter. It's a very versatile degree, sure, but if that's all that's stopping you, then you can always get your master's in something else to specialize, right? You can even just get another undergrad degree or an accreditation, you know, like Six Sigma, and like you can meet those steps. It's like, what's your end goal? Are you there for the team or not, right? You have to be a people person as an engineer, because you could be the most brilliant people and maybe you'll get that satisfaction, but for me, most engineers have to be people focused.
Yeah, I don't think it's like better than any other degree, but I thought it was versatile and like what I would want to work in. Like, you might be able to get your foot in the door with a degree, like in engineering in general, but the places that you might want to work in, the industries you want to work in, that's going to come from like your work ethic, how fast you can learn things, even if you got a job that's irrelevant, but you're showing that you know how to learn things quickly, and you're very like team oriented, and just like your networking skills in general are going to get you farther than just your degree will, for sure. Let's talk about specifically what internships and what internships did we all do, and what careers did we get into specifically? You can go first.
All right, yeah, because my story is more limited. So I worked for a little bit at Ford by virtue of Matt here. Got me into basically an internship space, but it was only for a brief period of time, and like, while I think it was useful for me to get used to the experience, it just didn't click. Basically, I took material samples, took images of them, tested them, and then it's intern work, right? It's grunt work. It is getting that, making a rough explanation of the trends, and it's something where it's someone that's pretty much a dedicated non-decision maker, right? Then I worked at F-Tech, and that was good for me, but also was spinning my wheels a little bit because they were able to let me extend my internship for quite a while. They paid me. They were very close to me, like in physical space. I can drive there. And what I did there was I was responsible for coordinating a number of plastics formulations. Didn't get to have the decision-making ability, right, that I think all of us really strive to have as professionals. But it was a lot of contacting people from different auto manufacturers, the tier one supplier of for PVC plastics. It's like really an industry you learn that time is money, because you see that because we're held up in the research lab, it affects our production space, and that holds up another company that can't make money if they can't get online fast enough. So that's a real cause and effect. Recently, I've gotten a job with I'm starting on Monday, and I'm excited, and hopefully I haven't ruined it in this interview, as a process engineer for a company called Soulbrain Michigan, which is a company that makes the lithium-ion electrolyte suspension liquid for the batteries themselves.
After we graduated, I don't know exactly how long it was. I think it was four-ish months. So between May and July. July was when I got hired to my current position at Ford. And again, this isn't really something. It's really not chemical engineering at all. It's more material science. Yeah, absolutely. I think that's part of the reason why I was able to get this job, because it definitely, my internship definitely ties in more to my current job than my major does. It's fine. I like what I do now. I do worry a little bit that I might lose some of my chemi knowledge the longer I stay at this job. Don't get me wrong, I have no plans of leaving yet. But yeah, it was essentially a materials testing laboratory, so we would get parts and cut them up and make samples and just do pictures using various forms of microscopy, and just sort of do failure analysis, so determining the failure modes for a part, whether it if it broke due to a fracture or a plastic deformation. All sorts of stuff like that. It was mainly metals though. We didn't really do much with polymers or anything like that. It wasn't really a chemical engineering related internship, but it was a really good experience, and I think most importantly, it got me introduced to the business culture at Ford. I felt I definitely fit in there just because it's a very laid back environment. I'm not saying that people are lazy, because they're not, but they treat their employees well, and they cater to their employees and make sure they have a good experience at work. I mean, I can't recommend it highly enough. So what I do now is compliance, like we work with the engineering side materials that are used in parts, and it's revolves mainly around government regulation based on where the vehicles are being sold. Essentially, like, there's a bunch of different things that I do at this job, but like the main purpose that we serve in our position is, I think Angith actually was the one who created this term, and I think it fits. We're like material police. We own the. You didn't say that?
Maybe I said it in passing.
I think you did, because I remember I got that term from you. But essentially, what we do is we have to hound suppliers and make sure that they use materials that comply with government regulations wherever they are.
Yeah, so I interned at an automotive supplier, and they only made wheels. So it was very material science related. And honestly, it was just like, it was whatever they needed. And I never really had any complaints. If it was like more like business related, I would do that. I would track their shipments and I would help send them out, or I did some Excel sheets for them. I did a few calculations for them, but it was really whatever they really needed. It was intern work for sure, yeah. Sometimes, yeah, because some days I would go and I would literally just be like packaging things. I would literally physically be packaging things, and I didn't mind because they just needed help at that point. So,
was that your only internship?
Yeah, it was. I had a few other offers, but I decided to stay with that one because I like the people a lot. They really all wanted to teach me about a broad range of things, and I learned a lot about the business side of things as well as the technical side of things. So,
and then what about after graduation? Because your job is pretty much the only one I know who's really applying everything you learn.
Yeah, so I work at a chemical plant, so I'm in charge of a few different processes. So we make silicon, so I'm in charge of the beginning of the process and the end of the process as far as making silicon.
And weren't you on a rotational program?
I was. So I was in the quality group, and then I was supposed to be in the process engineering group, but then I got moved to the manufacturing group.
Okay, and then what would you say are the biggest concepts that you use from what you learned in your time at undergrad?
I would say that I use a lot from my time at undergrad, just as far as the basic understanding, the process safety, and the weight of that when you're managing a big chemical process. I use a lot of thermodynamics in my job, a lot of energy efficiency. Distillation is very important, so I use a lot from the separations class. And then kinetics and reactor design. A lot of Aspen, that's a simulation software, so we use that a lot to try to understand exactly how our process is going to act, so how our inputs are going to react and what is going to be the output.
For me, I worked in the seating group in an automotive company, so in the interior seating group where I was in charge. I didn't actually do like that grit intern work. They just put me in charge of a project where they wanted me to improve one of their like prototype to production processes. Okay, after graduation actually, because I only did one internship in the automotive industry. After I graduated, I worked at an automotive company as a battery test engineer, so we would test batteries, but then I ended up leaving pretty soon just because I got a better offer. Now I'm working as a modeling engineer still in the automotive industry, where I like model different vehicle features. It really has nothing to do with chemical softwares. Just what advice would you give to somebody trying to become a chemical engineer?
Don't do it. No, I'm kidding.
I would probably say, like, this is just kind of a stereotype. People who go into engineering disciplines tend to be sort of introverts. You gotta break free of that cycle if you want to succeed in this. You gotta make like a network. You gotta get friends within your circle, in order to succeed. Because like, I don't know if you guys feel the same way, but I definitely feel like I wouldn't have made it through without you guys and everybody else in the class as well. I think it really brought everything together to have like a support group. That's my main thing. Don't be introverted.
Matt really touches a good point. I think we're responsible for the tropes that majors have, that like don't crap on people from other fields. quick advice for chemical engineer is prepare to fail, because it's not the experience of avoiding every failure. It's getting back up and readapting and readjusting. It's normal to fail. It should be normal to ask for help and get that support network. To just add on to Matt's point, that if you're in the right place, there are people to help you, and if there's absolutely no one at all, then you find a better place. You'd be surprised what you can survive. Losing your job or failing an exam, in the grand scheme of things, ends up not factoring in as much. Remembering to be a person. It's easy to dedicate all your time to your studies, but also the things you will remember won't just be your senior design project. It'll be going out late night to 3rd Street Bar, and it will be getting pizza, going to coffee, and it goes fast. That is a weird thing. You work for a third of there's a point where you pretty much just work for a third of your life after college, so appreciate the moments where you're not doing that.
Yeah, so I think when it comes to chemical engineering, it's kind of interpreted as the hardest. So there's going to be maybe a few people that you're going to come in contact with in your life that are going to say, oh, it's too hard and it might not be for you. So, just you can do it. Anybody can do it. It just comes down to hard work and who you surround yourself with. And, because the kind of group you have, they're going to help you get through it. So just to believe in yourself in the beginning, because I know I had moments where I doubted myself. Mm-hmm. And it really can be a really great experience at the end of the day. And I agree with Ungit too. It doesn't always matter if you get an A on the test. All that matters is that, you treated people the best that you could at the end of the day, and you made the friends that you could, and you had fun.
I think those were all really good points. I wanted to add that I think take advantage of all the resources you have around you. Don't work alone, right? Try to network, try to make a group of friends, because they will help you get through it. But also just college resources, you might have, there are different programs through Wayne State where you can get free tutoring. For Tau Beta Pi, we had free tutoring. Every course actually, you had TAs with it. And then with the Academic Success Center, you had free tutoring. But there were a lot of different resources. Even with the higher level courses, the engineering courses that didn't have TAs, they had the AICHE group. Through that, we had tutoring as well, right? We would have a tutor for different courses. So I think take advantage of all the resources you have and get to know your professors, because they are there to help you. I was pretty nervous sometimes to go to office hours for professors or TAs, but when I got more used to it, I really found it more helpful. The other thing I would say is get involved, because I did research during my undergrad in batteries for a couple of years, and I think that's what that research helped me to get my first job, even though that was unpaid research that I was doing. Try to go to the job fairs as well, right? Because a lot of us, we got internships by going to the job fairs at our school. And just try to get involved with things, because there's a lot of other groups like the Society of Women Engineers that the engineering group at your school might be able to offer. So, yeah. So, guys, do you have any last comments?
When Jaclyn said that literally anyone could be a chemical engineer, I think that's super important to stress. It's the right support network. It's the right timing, right? You're not this divine gift to the world that we need increasingly diverse chemical engineering fields, right? If you feel like it's not your field but you're interested in the material, we need you, right? We need the introverted types. We need the types that might be more creatively focused, right? The worst thing we could do to our industry in general is try to produce the same engineer 100 different times.
Okay, guys. Well, thank you so much for joining. I think that was really informative. Especially if I was a student wanting to pursue this degree, I think it would be helpful to hear from other graduates on different perspectives.
Thank you for having me, Neha.
You're welcome.
Thank you for having me.
And that's a wrap. Thanks for tuning into today's episode, and we'll see you next time.